Virtual field labs. If you joined us today, you probably saw that title, Virtual Field Labs, and you're joining to figure out what on earth are these virtual field labs. I'm Bill Grosser with the U.S. Ice Drilling Program, and I'd like to share with you this unique new product that we're calling Virtual Field Labs. They're not field trips. They're not laboratory experiences. They're kind of a hybrid of the two, presented in three-part video series, hence the name, Virtual Field Labs. We think it's a new approach that combines really the best of being in a lab with scientists and seeing what they do, along with traditional classroom laboratories where students are engaged in all sorts of science process skills on their own in their own notebooks. Each one of the virtual field labs joins a leading climate scientist as they analyze data to answer a specific climate question. The nice thing is it's developed for students aged middle school all the way up through college. And they are designed also so that students can watch them independently, or if a teacher chooses to, they can actually show them in their classroom and they can all do the learning together in that environment as well. So one thing we know about teaching is that students learn best when they have a personal connection with that person who is doing the teaching, their teacher in this case, or in this case with the virtual field labs, the scientist. So we recognize that. So each of these virtual field labs starts with part one, which is a short 5 to 8 minute long video segment where the climate scientist gets to introduce themselves, introduces their family. You get to meet the family dog sometimes, you get to know their hobbies, and hopefully there's a connection made there between that scientist and the students so that the learning can then be much more meaningful. We'll show you a couple little clips here, and you can get to know our two scientists for the two series that we have finished at this point, Dr. Eric Osterberg and Dr. Meredith Kelly.
Recently, before I moved to Dartmouth, I lived in New York City and worked at an Earth Observatory with more than 300 students, 300 other research scientists and students who worked there too. And I have a wonderful family. I have 3 kids. I have a 5-year-old daughter and twin boys who are 2. So I have my hands full at home.
We also know that students connect to people who look like them. The different virtual field labs that we've produced so far all feature different climate scientists, different teachers, and different students that represent a full range of gender and ethnic diversity. Our hope is that every student can see themselves in one of those people on the screen doing the teaching. Even more so, our hope is that they can see themselves after this getting more involved in climate science and actively addressing the climate crisis that we're all facing together. So let's talk for a minute about how each virtual field lab series is designed. Each series consists of 3 different parts. Each part ranges from 8 minutes to about 35 minutes. We tried to keep them perfectly designed lengthwise to fit into a typical classroom schedule. In part 1 of each series, climate scientists introduce themselves, like I said before, both personal and professional level, and the students get to meet their families, hobbies, visit their labs, learn about their specialty in the area of climate science. At the end of part 1 of each series, the climate scientist introduces a specific climate question that's going to be investigated in the following parts 2 and 3. We'll take a minute here and I'll share with you a couple little clips to show you what it looks like.
How do we know this information about the last ice age and ice sheets and how they were treated? Well, this is really an amazing question to ask. And in fact, it's information that's right below our feet. It's preserved in the landforms and the sediments that make up the landforms. And by interpreting these landforms and sediments, we can get information about the past that then we hope will be able to provide information about how ice sheets today may respond to climate change. So the question that we're going to ask today is, what do observations and measurements of the landscape around us tell us about past environments?
In part 2 of each series, the focus shifts to really engaging students in those science process skills. This is where the lab part comes in. of the virtual field lab. Students get to join these climate scientists as the scientists themselves collect samples out in the field, so they get to see what that whole process is like. And then they get to join each climate scientist as they return to their labs and some of the leading labs in the country to analyze those samples to see what that data can tell us about the climate and the specific climate question that's being investigated in each series. Students in each part of that are challenged to make their own measurements sometimes, their own drawings, their own observations, and their own interpretations of the data. The student focus is constantly turned back to that one single climate question being investigated throughout that series. So I'll share with you here a couple examples so you can get a feel for what it's like.
All right, so now we have all of our ice core samples. We've scraped off the outside that might be contaminated. We put those samples into the clean jars, and those clean jars have now been sitting under clean air and allowing the ice samples to melt. So now in each one of those jars is water that represents that section of ice core that we sampled in the freezer. So now we just have to put those in the vials that we can actually load in the instrument and then to measure the chemistry and see what's going on, see if we can see any evidence of a climate disruption.
One of the things we tried to emphasize throughout the virtual field labs are just these fundamental process skills that are embedded in the next generation science standards, if your state or university follows those, or just good science practices. Students are involved in scientific drawing, they're involved in graphing, they're involved in creating data tables, they're involved in analyzing that data themselves, and they're involved in drawing their own conclusions from that data. Deliberate pauses are built into each series so that students don't get rushed, so that they have time to catch up, so that they have time to think, they have time to process themselves. This also makes it nice to either teach in a synchronous environment or an asynchronous environment, depending upon how things are going this year, and even after COVID, how you might want to teach in the future. Again, students can watch these on their own as almost like a homework assignment or independently, or a teacher can use this to drive a lesson forward in the classroom themselves, pause, enhance throughout the entire video. So let's take a minute, we'll pause, and we'll look at some of those fundamental process skills in action. Hey, welcome back. So now you should have your completed data table and your completed graph, but now your graph is in elephants per second being lost from the Greenland ice sheet. That graph tells a really nice story. So what I'd like you to do is, next to that graph, somewhere in your notebook, can you write down 2 things that you notice about your graph and 1 thing that you wonder? Like I mentioned earlier, each of the virtual field labs consists of 3 parts. In part 1, the scientist gets to introduce themselves, you get to know them personally and professionally, and the climate question being investigated is introduced. In part 2, we go into the field with the scientists and into their labs, and together we collect data, analyze data, make graphs, and we use all the science process skills. Part 3 is where we really turn it over to that climate scientist. In part 3, each climate scientist has an opportunity to share their own interpretation of the data, so that students can compare what they thought with what the climate scientists thought. And they also have a minute or 2 to explain their interpretation of what that data means for our collective climate future. So we'll show you a couple clips here and you can get a feel for what that is as well.
And what scientists have said, they have proven that those warmer oceans that Bill talked about, those warmer oceans are the key reason why we're seeing so many hurricanes these days and why so many of them are so powerful and devastating. So it's all connected to those rising greenhouse gas emissions from human activities.
At this time, we have 2 full sets of 3 virtual field labs ready for distribution. The first series is with Dr. Eric Osterberg of Dartmouth University. Dr. Osterberg explores abrupt climate disruptions. He does it in a unique way. First, he looks back into the past to see abrupt climate disruptions in the past and what those data markers look like. Then he looks at data markers in places like Greenland today to see if we now have evidence that an abrupt climate disruption is taking place in our current climate. The second series that's complete is with Dr. Meredith Kelly, also of Dartmouth University. She looks at climate clues in the past and glacial features, so glacial features that are found all around us. And she looks at how those clues in the glacial features around us are really a window into the types of abrupt changes that we might see in the great ice sheets today in the North Pole and South Pole areas. All the virtual field labs are provided free through funding from the National Science Foundation and the U.S. Ice Drilling Program, and they're all available at icedrill-education.org. Again, all free, all at icedrill-education.org. So thank you for joining me on this little whirlwind tour of these virtual field labs. We're really excited to get them into the hands of students and teachers across the country. Anything you can do to help us with that would be appreciated. Feel free to share with your colleagues, with anybody who's interested in climate education in general. We're really hoping that these will be a tool that teachers can use to help build the next generation of both climate scientists and the next generation of just climate literate citizens. Virtual field labs, entirely new concept. Enjoy.